National Electrical Code Section 348.12 UN addresses the permitted uses of flexible metal conduit, commonly referred to as FMC. Specifically, it outlines situations where FMC is not allowed. One of the restrictions is its use in wet locations. However, there is an exception to this rule. The exception states that FMC can be used in wet locations if two conditions are met. Firstly, the conductors inside the FMC must be approved for wet location use, and secondly, the installation must be such that liquid is not likely to enter the raceways or enclosures to which the conduit is connected. It's crucial to understand both parts of this exception. The first part focuses on the conductors themselves. If the wires inside the FMC are specifically designed and approved to withstand wet conditions, they meet the first requirement. This means the wire insulation is made of a material that doesn't degrade or fail when exposed to moisture. The second part of the exception is about preventing water from entering the system. This involves ensuring that the FMC connectors and any enclosures connected to it are installed in a way that minimizes the chance of water ingress. This can be achieved through several methods, which will be discussed later. Now let's consider the scenario of a walk-in cooler. Walk-in coolers present a unique situation because while they are refrigerated and might seem like wet environments, their interiors are often relatively dry due to the constant cooling process. However, because of condensation and potential moisture, they are generally classified as damp or wet locations under the National Electrical Code. When installing electrical components in a walk-in cooler, it's essential to select equipment rated for wet locations. This ensures that the equipment can withstand the environmental conditions without failing or becoming a safety hazard. This includes lighting fixtures, door heaters, and any other electrical devices inside the cooler. If all the equipment is wet location rated, it meets one of the key requirements for using FMC in this environment. The interior of a walk-in cooler is typically dry due to its temperature-controlled nature. The refrigeration system constantly removes moisture from the air, which helps to keep the inside dry. Additionally, components like door heaters and lighting fixtures generate heat, which further reduces the likelihood of moisture accumulation. If the environment inside the cooler is generally dry, it supports the argument that liquid is not likely to enter the FMC raceways. There are several measures that can be taken to prevent liquid from entering the FMC raceways. 1. Using watertight connectors and fittings. These connectors are designed to create a seal that prevents water from entering the conduit. 2. Sealing the entrances of the raceways with silicone or other approved sealant. This provides an additional barrier against moisture. 3. Positioning the raceways in areas where they are less likely to encounter liquid. For example, running the conduit along the ceiling or high on the walls can reduce its exposure to water. Using watertight connectors and fittings is critical for preventing moisture from entering the FMC system. These connectors typically have rubber gaskets or O-rings that create a tight seal when properly installed. They are specifically designed to prevent water from seeping into the conduit, which helps to maintain a dry environment inside the raceway. When selecting connectors, make sure they are listed and labeled for wet location use. This ensures that they meet the necessary standards for moisture protection. Another effective measure is to seal the entrances of the raceways with silicone or other approved sealant. This involves applying a bead of sealant around the point where the FMC enters an enclosure or junction box. The sealant creates a barrier that prevents water from entering the raceway through any small gaps or openings. Make sure to use a sealant that is specifically designed for electrical applications and is compatible with the materials being sealed. Proper positioning of the raceways can also help to minimize their exposure to moisture. Avoid running the conduit in areas where water is likely to accumulate, such as along the floor or near drains. Instead, try to run the conduit along the ceiling or high on the walls where it is less likely to come into contact with water. Additionally, consider the location of any potential sources of moisture, such as condensation from refrigeration equipment, and position the raceways away from these areas. In many areas, it is common practice to use FMC in walk-in coolers because the equipment is rated for wet locations and the interior of the cooler is typically dry. This practice is based on the understanding that the conditions inside the cooler meet the requirements of National Electrical Code Section 348.12. The local electrical inspector may be unfamiliar with this practice or may have a different interpretation of the code. It's important to be prepared to explain the reasoning behind the installation and provide supporting evidence. You can start by explaining the exception in National Electrical Code Section 348.12 and how it applies to the specific installation. Emphasize that the conductors are approved for wet location use and that measures have been taken to prevent liquid from entering the raceways. Next, highlight the fact that all the equipment installed in the cooler is rated for wet locations. This demonstrates that the equipment is designed to withstand the environmental conditions inside the cooler. Explain that the interior of the cooler is typically dry due to the temperature-controlled nature of the unit. The refrigeration system constantly removes moisture from the air, which helps to keep the inside dry. Describe any additional measures that have been taken to prevent liquid from entering the FMC raceways, such as using watertight connectors and fittings, sealing the entrances of the raceways, and positioning the raceways in areas where they are less likely to encounter liquid. Show the inspector that the installation is safe and reliable because the FMC is protected against moisture entry and the equipment is designed for wet locations. Explain that the installation meets the requirements of National Electrical Code Section 348.12 and that it is consistent with common practice in the area. If the inspector is still hesitant, politely ask them to reconsider their decision based on the explanations and supporting evidence. You can also offer to provide additional documentation or to consult with a senior inspector or code official. Remember to remain respectful and professional throughout the discussion. The goal is to educate the inspector and to come to a mutually agreeable solution that ensures the safety and compliance of the installation. In addition to the general guidelines outlined above, there are some specific considerations to keep in mind when using FMC in wet locations. Firstly, ensure that the FMC itself is listed for wet location use. Some types of FMC are specifically designed to be used in wet environments and have additional features to protect against moisture. Secondly, use only approved connectors and fittings that are specifically listed for wet location use. These connectors are designed to create a watertight seal and prevent water from entering the conduit. Thirdly, when sealing the entrances of the raceways, use a sealant that is compatible with the materials being sealed. Some sealants can damage certain types of conduit or enclosures, so it's important to choose the right sealant for the job. Fourthly, inspect the installation regularly to ensure that there are no signs of moisture damage or corrosion. If any problems are detected, take immediate action to correct them. Fifthly, consult with a qualified electrical engineer or inspector if you have any questions or concerns about the installation. They can provide valuable guidance and ensure that the installation meets all applicable codes and standards. When working with electrical systems in wet locations, safety should always be the top priority. Firstly, always energize the circuit before working on any electrical components. Secondly, use appropriate personal protective equipment, such as rubber gloves and safety glasses. Thirdly, follow all applicable codes and standards. Fourthly, if you are not qualified to perform electrical work, hire a licensed electrician. By following these safety precautions, you can minimize the risk of electrical shock and other hazards. To summarize, using flexible metal conduit in wet locations is permissible under National Electrical Code Section 348.12 if the conductors are approved for wet location use and the installation is designed to prevent liquid from entering the raceways. When installing FMC in a walk-in cooler, it's important to use wet location rated equipment, take measures to prevent moisture entry, and be prepared to explain the reasoning behind the installation to the electrical inspector. By following these guidelines, you can ensure a safe and compliant electrical installation. Let's delve deeper into the specifics of selecting conductors approved for wet locations. Conductors used in electrical wiring are typically insulated to prevent electrical current from escaping and to protect people from electric shock. The type of insulation used on a conductor determines its suitability for different environments. For wet locations, conductors must have insulation that is specifically designed to withstand moisture. Several types of conductors are approved for wet locations. One common type is type THWN. This type of conductor has a thermoplastic high water resistant nylon jacket insulation. The nylon jacket provides added protection against moisture and abrasion. Another type of conductor approved for wet locations is type XHHW. This type of conductor has a cross-linked polyethylene insulation. Cross-linked polyethylene is a thermoset material that is highly resistant to moisture, chemicals, and high temperatures. When selecting conductors for a wet location, it's important to check the conductor's markings to ensure that it is approved for wet location use. The conductor's markings will typically include the type of insulation, such as THWN or XHHW, as well as other information such as the conductor's size and voltage rating. In addition to selecting conductors approved for wet locations, it's also important to ensure that the conductors are properly installed. This includes using appropriate connectors and fittings that are designed to prevent moisture from entering the raceway. The connectors should be listed and labeled for wet location use and should be installed according to the manufacturer's instructions. When pulling conductors through the conduit, be careful not to damage the insulation. Damaged insulation can allow moisture to enter the conductor and can create a safety hazard. If the insulation is damaged, the conductor should be replaced. Once the conductors are installed, inspect them to ensure that there are no signs of damage or corrosion. If any problems are detected, take immediate action to correct them. Let's now shift our focus to the importance of preventing liquid from entering the raceways. As mentioned earlier, National Electrical Code Section 348.12 requires that the installation be designed to prevent liquid from entering the raceways. This means taking measures to ensure that water cannot seep into the conduit and come into contact with the conductors. There are several ways to prevent liquid from entering the raceways. Firstly, using watertight connectors and fittings. Watertight connectors are designed to create a seal that prevents water from entering the conduit. They typically have rubber gaskets or O-rings that create a tight seal when properly installed. When selecting connectors, make sure they are listed and labeled for wet location use. This ensures that they meet the necessary standards for moisture protection. Secondly, sealing the entrances of the raceways with silicone or other approved sealant. This involves applying a bead of sealant around the point where the FMC enters an enclosure or junction box. The sealant creates a barrier that prevents water from entering the raceway through any small gaps or openings. Make sure to use a sealant that is specifically designed for electrical applications and is compatible with the materials being sealed. Thirdly, positioning the raceways in areas where they are less likely to encounter liquid. Avoid running the conduit in areas where water is likely to accumulate, such as along the floor or near drains. Instead, try to run the conduit along the ceiling or high on the walls where it is less likely to come into contact with water. Additionally, consider the location of any potential sources of moisture, such as condensation from refrigeration equipment, and position the raceways away from these areas. Fourthly, using drip loops. A drip loop is a section of conduit that is routed downwards to create a low point where water can collect and drip off. This prevents water from running along the conduit and entering the enclosure. Drip loops are commonly used in outdoor installations where the conduit is exposed to rain. Fifthly, using condensation fittings. Condensation fittings are designed to collect condensation that forms inside the conduit and drain it away. These fittings are typically installed at the lowest point of the conduit run and have a small drain hole that allows the water to escape. Condensation fittings are particularly useful in environments where there is a significant temperature difference between the inside and outside of the conduit, such as in walk-in coolers. In addition to these measures, it's also important to regularly inspect the installation for any signs of water damage or corrosion. If any problems are detected, take immediate action to correct them. This may involve replacing damaged connectors, resealing the entrances of the raceways, or rerouting the conduit to avoid areas where water is likely to accumulate. Maintaining a dry environment inside the raceways is essential for ensuring the safety and reliability of the electrical system. Moisture can cause corrosion, which can lead to electrical shorts, equipment failure, and even fires. By taking the necessary precautions to prevent liquid from entering the raceways, you can protect the electrical system and ensure its long-term performance. Now let's address some common misconceptions about using flexible metal conduit in wet locations. One common misconception is that FMC is never allowed in wet locations. While it is true that National Electrical Code Section 348.12 prohibits the use of FMC in wet locations under certain circumstances, it also provides an exception for situations where the conductors are approved for wet location use and the installation is designed to prevent liquid from entering the raceways. Another misconception is that simply using wet location rated equipment is sufficient to comply with the code. While using wet location rated equipment is certainly important, it is not the only requirement. You must also ensure that the conductors are approved for wet location use and that measures are taken to prevent liquid from entering the raceways. A third misconception is that sealing the entrances of the raceways with silicone is all that is needed to prevent moisture entry. While sealing the entrances of the raceways is a good practice, it is not a foolproof solution. Water can still enter the conduit through other means, such as through damaged connectors or through condensation. It's important to use a combination of methods to prevent moisture entry and to regularly inspect the installation for any signs of water damage. By understanding these common misconceptions and taking the necessary precautions, you can ensure that your FMC installation complies with the National Electrical Code and provides a safe and reliable electrical system.